Example 14, we want to prove limit of x as x approaches to infinity of 1 over x equal to 0 using definition number 7. So if we apply definition number 7, we can see that this is the L and this is the function f of x. So we want to show that if we have the x greater than n, then the distance between f of x, which is 1 over x, minus L, which is 0, less than epsilon. So this is mean that 1 over x less than epsilon. But we assume that the x will be a positive number. The reason why is that x go to a really large number positive. So x will be a positive. So we can take off the absolute value and then we can solve for x. Then we get x less than 1 over epsilon. So now we will choose, or we switch this, right? So we solve, so we switch this. So we can say that the n and the 1 over epsilon, so we will choose n to be 1 over epsilon. So step number 2 is that we just verify what we did. So we just like redo what we did, okay? So for every epsilon greater than 0, and if we have, copy this sentence one more time, okay? If we have x greater than n, we're gonna follow from this, okay? If x greater than from n, then we have the function 1 over x minus 0. Okay, so what do we want at the end? We want at the end to be the epsilon and less than epsilon. That's what we want at the end, okay? So it's equal to 1 over x, and the x is positive number, then we can open this, so it's equal to 1 over x. So if we know that x greater than n, that means 1 over x will be less than 1 over n, okay? So it's less than 1 over n. And because we choose n to be 1 over epsilon from here, so let's plug it in. So 1 over epsilon. Then it will equal to, simplify this, it will equal to epsilon. So this is proof that the limit as x approaches to infinity of 1 over x equal to 0. The last definition of an infinite limit at infinity. So let's f be a function defined on some interval from a to infinity, then the limit of f of x as x approaches to infinity equal to infinity. So it means that for a positive number m, there is a correspond positive number n such that x greater than n, then f of x greater than m. Now let's look at the picture. So we have the function f of x in the blue color, and we pick a value m on the function on the y part, and then we map back to the function to get the value n. And with the definition saying that if we have the x value is greater than n, so the x value in the yellow, okay, in the yellow, then for sure we will have go back to the function, we map back to the function, then we will have a value of f of x, which is the y part, this is y, greater than m, okay? Then we will have the function f of x will approach to infinity as x approach to infinity.